Hello, my name is John Pacey. I'm the Director of Cloud Development here at Wolfram Research, and today I'm just going to give a talk or overview on the state of the Wolfram Cloud. I'm going to talk about a brief review of Wolfram Cloud capabilities, explain some key features of the Wolfram Cloud environment, also talk about some differences between the cloud environment and desktop. We'll go over our roadmap and priorities as well. I also want to mention some related talks. So we have a general cloud office hours later today at 11:30. So come join and ask more direct questions there. I'll be there along with other cloud developer team lead meetings members for that. And there's the Wolfram Compute Services preview tomorrow, which is Friday at 11:30, which is also sort of cloud adjacent. And so a little bit towards the end of my talk, hopefully I have about 5 minutes left to ask a few questions if we can. And what I'll be doing here in my presentation, I'll be switching between this desktop presentation notebook and a cloud notebook. But just a reminder, hopefully everyone is aware. So wolframcloud.com is a web application where you can work with notebooks and write Wolfram language code in a web browser. You can also just share interactive notebooks and other arbitrary content, and you can deploy applications written in Wolfram language via API function, form function, and similar. And in general, it's a very powerful hybrid desktop and cloud workflow. It's not a desktop replacement. You can do a lot of things there, and that could fit your needs, but we really want to be using you in combination with our desktop products. Okay. And you can work with notebooks. So I'll go ahead and switch over to my cloud notebook here. Right. So I set this up a little bit before. And so again, this looks very familiar to the desktop environment. Here I'm going to just evaluate a plot and then a basic manipulate. And then something even like tabular here. And so you're evaluating things from your browser, and that's going to talk to our servers and then send back the result. Okay. Right. And then one of the key things that we add with Wolfram Cloud is to be able to share it. So via Cloud Publish. So for example, if I switch back to my cloud notebook, I can share and publish that, which we'll talk about a little bit later. Okay. Right. And again, as I mentioned, it's a hybrid situation where you can work from desktop. So here, again, I'm in my notebook, my desktop notebook. I will Cloud Connect as me, and my little magic trick or trying to prove to you that it's some difference. So this is the process ID that's running on my local machine. Whoops. And then here I'll do a cloud evaluate, which will use my connection to the public cloud, and that'll give me a different process ID. So again, I initiate the evaluation from my desktop. It evaluates over in our cloud environment, and then the result comes back. Again, the power of cloud deploy of what we talked about in this case is an API function. So I'll go ahead and deploy an API function, and we will view that in our browser. And here we've associated URL. In this case, it's this wolframcloud.com obj and a UUID with that deployed content. And so our servers handle that routing and mapping to say, hey, this is going to be an API function, and it's even going to tell me the success here is false. I could not be evaluated because there was no input. So it's going to tell me, I need to actually provide an input. And in this case, our parameter was X. So I'll just say X was 100 and then revisit this. And then it executed our API function. In this case, it was a very, very simple API function of just factor integer of that, which looks correct for that. So again, extremely powerful. I just deployed that as is. Very useful and quick, again, hybrid workflow there. So that's a very basic API function. We have the concept of form functions, and then you can also do some other more complicated things in terms of building up features that you want to do with these lower level primitives of API function, HTTP redirecting, and including a form function, which I won't go over here, but there's lots of great examples, and you can do that. I want to make sure I get onto other parts of my talk. Okay. more on the web side of things. So we've got the ability to deploy notebooks in a web environment. Well, how can I have those interact with other HTML frameworks or tools? And that's where we're going to talk about embedding notebooks and internal notebooks. So we have the notebook embedder, which is a JavaScript library that we published and provided that allows you to embed public notebooks via JavaScript in your other uh, web HTML type things, which I'll give an example of here in a minute. You can also view and render notebooks, given by a URL or an expression. So here I'm going to go to the wolframcloud.com and I'm going to give it a special parameter to say, hey, I have a notebook that's publicly reachable at this URL. Let's go ahead and view that. So if I click on that, took a little bit there, but so again, wolframcloud.com, and I give it a URL. It reads that notebook and on the fly goes ahead and renders it. So that's pretty cool, right? And then you can do the same thing with giving an expression directly. So this is a percent encoded notebook expression with some basic text in it. And again, when I go there, it's on the fly creating that. So if I refresh, you can see my very simple hello world there. Okay. All right. Before I get there, I'll go ahead and sort of show off some of this embedding in my other notebook here. Okay, so here is the notebook that I just created. I'm going to go ahead and use it. And then what I'm going to do here is actually do some live editing of HTML. So we primarily work with notebook files, but you can do other files as well, including text and HTML. So I'm going to do a very basic example here. I wouldn't suggest building everything out directly in our editor. I think for larger projects, you still want to use a desktop editor or templating or even generating HTML in Wolfram language and deploying it. But for this one, I'll show you a basic example. So here I have my HTML. And right now I'm in the environment view, which I'll talk about in a minute. This lets me do editing and so forth. And so I can do that. So I have a very basic HTML here. Let's go ahead and delete that guy. And then I'm going to switch my view, which again, I'll talk about in a minute, to deployed. And what that's going to do is say, okay, I know that this is an HTML file, so I'm just going to give it to the browser to render. And there's my hello world. If I switch back over to the env view, hello world again. And again, so there's some auto saving there, but I'll just go to the OBJ and refresh, and there's my change. Okay. And so I can do some basic HTML editing here that I want to do, just kind of showing that and showing off the difference between the environment view, which is editing, and the OBJ view or deployed view, which is kind of viewing. All right, so here's our GitHub page for the Wolfram Notebook Embedder, and there's some examples. And I will pick one here, which is borders. I'll go ahead and get the raw HTML there, copy it. We're going to go ahead and dump that into our HTML. And I will make one change, which is some more web-based things in terms of where I'm getting the Wolfram Notebook Embedder from. And so there I've made my changes, completely changed that same, the underlying content of that same HTML file. And I'm going to refresh there, so it picks that up, and there we go. So this was, again, the stock example from our GitHub account. I'll go ahead and change the underlying example that I want. So again, just showing that I can change this on the fly, and we very quickly pick that up. So instead of using Jan's example, I will use my version of that. Okay. All right, again, refresh, there it is, and then click my embed notebook, and there we go. So this is, again, using the Wolfram Notebook Embedder. It's going to take my public notebook that I have already existing, and it's going to go ahead and embed that. And this basic example shows you with some parameters to the notebook embedder to do with borders and without, although you may not be able to see them through that. So there we go. And we can go ahead and put any public URL or public notebook that we want to have in there. And so here's the notebook that I've been using. The options there, our permissions on that are only for owner, but I'll go ahead and put those permissions to be public. And then we'll go ahead and get my link here, and we will again edit our show borders example just to prove we can do it. We will stick in the URL we just got. And again, switching from the editing view to the OBJ view and embed notebook. And there you see, that's the notebook that we just edited and made changes to in real time. Okay. All right. So hopefully that's a little bit of the power of showing that kind of hybrid workflow, which I talked about. Okay. Another big question is, well, we've talked about how cloud environment is different from desktop a little bit. How do I know what things are supported or what's going to be different? Which is a great question, and one we're continually working on improving. And one of the ways you can do that is programmatically through the language in terms of Wolfram language data. So the cloud support status is in Wolfram language data, and there are two keys for this. There's cloud support status. There's also cloud support notes. And so we have this that's programmatic, and in this case, plot is generally supported. We say geometric scene is not supported, and then we can have things that are sort of partially supported. So in this case, we say inset is partially supported, and well, what do we mean by partially supported? Let's take a look at the support notes, and it means that the positioning does not always match desktop behavior. It could be off by a few pixels due to font differences or other things there. And then, that's more around functions that are more notebook driven. It's also talking about sort of kernel driven functions. In this case, financial data is partially supported, and the support notes there is the usage limited to cloud notebooks, and the use in cloud deployed forms and APIs is restricted primarily for licensing and other reasons there. And then there are other kernel functions that we disable more from a security level. So in this case, run process is restricted in public cloud. And if you look at the support notes for that, it can work in a private cloud if the sandbox is disabled. And that is just primarily around security concerns. We're running in a shared environment where we do sandbox your code and other things there, but we also disable some things for security reasons in our public cloud. And the good thing about this being programmatically accessible from the language is that this will be utilized to also update and maintain the HTML documentation. So here for run process, you'll see a restricted in public cloud or partially supported and other tags here that are coming from Wolfram language data. So again, this is something we're constantly trying to improve and keep up to date. And so, be on the lookout for changes there. And if something isn't clear, go ahead and ask us. Okay. All right, so that's a brief programmatic way to look at what's different. I want to review some key concepts of the public cloud environment, which I'd usually do in all of my talks. So in general, we're running on Linux virtual machines or with underlying hardware, which currently for our public cloud means no GPU access. There are per user limits on overall storage, so how many files you can have or how much file storage you can have in terms of memory. And then for each evaluation, there are memory and time constraints. So back in my cloud notebook, yep. So, if I make a computation, which is like pause of, I don't know, 120 seconds, that's probably going to hit my evaluation time limit before it actually gets to 120 seconds. So, the evaluation will get cut off. You get a message saying you exceeded your time limit or a memory limit or things there and so forth. So, okay. As I mentioned before, we limit or disallow certain functions for security reasons. And we use a combination of different sandboxing techniques to still isolate execution of your user code from another user code. So again, it's a shared environment, but you're segmented from other users. As I mentioned before, all of those above restrictions in terms of security, disabling of features or enabling or disabling different parts of the sandbox can be reconfigured or changed in a custom or enterprise solution to fit your needs. And as I mentioned before in related talks, we have a new offering coming soon with Wolfram Compute Services, which gives you even more direct control and isolation for your specific longer running evaluations, including access to, possibly to GPU instances and so forth. So there's a conference talk tomorrow at 11:30 about that. I strongly encourage you to look at that in terms of additional specific customized options for executing Wolfram language code in a nice environment. Okay. Let's see. All right. One other key thing that I want to talk about in cloud is the kernel types. So in the desktop environment, you are typically using the front end, and you're setting up different kernels that are associated with your front end session. We still have a concept of different kernels in the cloud. So there are two main types. There's actually some more, but I'm going to focus on these two here. There's the session kernel and what we call public. So a session kernel is your long-lived kernel that's assigned to a single user and when you're editing a notebook. So this is very analogous to the desktop kernel that you have in your kernel configuration, your default kernel, and it's going to be there. It's going to be shared between notebooks that are in the same front-end session, and it's going to stay alive as long as the program's running. You don't quit it, or if you run something that quits it. And for the most part, that's how it also works in cloud. And then there's the public kernel type, which is a short-lived kernel. Again, it's still assigned to a single user, and almost always its lifetime is only for a single evaluation. And in particular, for when you execute an API function or a form function, that's basically just a one-shot evaluation. It's here's a kernel, we configure it and isolate it for that user. It loads in the specific Wolfram language code associated with your API function or form function, executes it, and is done. And then that kernel goes away. And then the next time you evaluate the API function or the form function, you're going to get a fresh kernel to do that. Okay? And the other use of these public kernels is for when you're working with or interacting with deployed notebooks and a deploy manipulate, which I'll talk about in a second. And in that case, it's still short or lived, but it's gonna stick around a little bit longer than just a single evaluation, but it's still shorter lived. So the key thing to note here about cloud is we have different kernel types. It's primarily based off of the view or the type of thing you're doing, which again, I'll talk about a little bit in a little bit. And a key thing when you're reporting a bug or trying to understand some behavior is if it works in the environment view or the session, but it doesn't work in the deployed view, that means there's a problem with how we're handling the kernels there. And that's a key information to report to us for that. Okay. So those types of kernels are very much tied to the view, and this is what I sort of talked about earlier in terms of editing versus deployed. And all cloud notebooks are cloud objects, and again, all files in the cloud are cloud objects. You have a file that we associate on the file system with our database, and then you distinguish certain things about those types of cloud objects. In particular, notebooks, we have a specific MIME type generally, and then how that cloud object gets displayed when you access in a web browser ultimately depends on the view. And that view is determined by some logic. You can either specifically say it with a parameter, a path prefix, which is what I talked about before in the env versus obj, and then there's just a default behavior. And most of the time, you don't have to worry about this. You can programmatically control this through cloud object URL type. So in this case, I'm generating a general object, and I want the URL type to be environment, and it's going to generate the env view. The most common switch, which you saw me do before, is between the environment view and the deployed view. So environment view is editing. That's going to have the longer-lived session kernel, and the deployed view has the shorter-lived kernel as far as notebooks are concerned. Okay. All right, and there's additional details on a link that I have here that gets into, goes through some of this nuances of this as well and other things about notebooks. But again, just to sort of make this make sense, here, this is the env view with my notebook. And so that means I get a long-lived session kernel. So if I do my process ID there, it should be sticking around from what I had. And this is going to, again, stick around as long as I did that. If I switch over to the deployed view, let's see, the OBJ. So here, again, I can't edit it here, but I can interact. And my kernel is going to be a different one, and it'll be generally shorter lived for that. So, okay. All right, going kind of quickly through that. Another key thing that I always want to reiterate is a key difference between desktop, front end and kernel communication is the amount of communication overhead. So, when you're typically running things in a desktop session, you have the front end process, which is the whole notebook interface that you typically use, and that's communicating with the actual underlying kernel. and those the kernel and the front end talk back and forth to each other depending on different things in your notebook. Since they're running side by side in the same machine, there's pretty much no overhead there, so there's no latency in that communication. But in the cloud environment, the public cloud environment, the front end is your browser and the kernel is on our server. So anytime that the front end would typically have to talk to the kernel, that needs to make a network request. So possibility of a lot more network latency. And a key thing to talk about in terms of trying to understand performance bottlenecks or optimizing things is looking at a link snooper kernel configuration in your desktop kernel to see, okay, how much traffic is there, how much traffic is there going between the front end and the kernel, and can I eliminate or reduce that to have better performance in cloud? So that's just a thing I like to always point out. Okay, so moving on to, well, how is the cloud useful? So, obviously you can use it for the examples that I showed in terms of generating some content, showing it and sharing things, but it has a lot wider range of applications than that. And we keep building more and more things on top of the cloud in terms of our Wolfram technology stack. And even in desktop, a lot of the things that you're using, if you utilize Packlets or any of the resource functions or any of the other repositories, that's relying or built on top of cloud. So for example, the Packlet repository, parts of that are hosted in cloud. And so a lot of the things that you use in desktop still rely on cloud, even if you're not just directly using it. So one key thing is our LLM integrations. So a lot of the offerings that we have, or maybe been talked about in other talks, for making things more publicly available are basically using deployments in our public cloud or possibly in a separate private cloud instance to basically some version of API functions or other things there as part of endpoints, as part of Wolfram language integration. And we've used this for several years now in terms of initial integrations with ChatGPT plugins and also with MCP protocols and servers and so forth. So again, some of those things can also be done locally using your own Wolfram engine instances, but we have more public ones available, and that's built on top of cloud. As I mentioned before, we have the resource system as well. So that keeps expanding and relying on cloud, and those are there's myriad things there for that. So the function repository not only hosts the code, but it also hosts their pages, and that's a combination of HTML that's generated in Wolfram language and deployed API functions and other things there. Wolfram community utilizes the Wolfram notebook embedder as the key part of posting notebooks for that. Wolfram U, again, also utilizes notebook embedder, deployed API functions, deployed form functions, deployed notebooks, and other HTML content in a hybrid way. We also have our Wolfram language playground, which is provides a sandbox to evaluate and try experiment with the Wolfram language without requiring a sign-in. And there are all kinds of other internal and other external customized applications that are built on top of cloud technology. So we have customized ERP solutions for our company and for others. We have lots of log analysis and task systems built on top of that. Again, custom LLM integrations and solutions for enterprises. We also have internal development instances for either working on Mathematica or just even cross-team sharing of materials and content. And again, a primary internal development platform for developing new features across the company, tracking and planning of agendas, custom dashboards, bug tracking, build monitoring, all kinds of other things. All right. Okay, so where are we going? What have been some key updates or priorities? So we're always trying to maintain compatibility and parity with desktop features. One of those things is tabular, which I will switch back to my notebook, cloud notebook. So if you may have noticed here for my tabular example, whoops, that's the deployed view, not my environment view. So for the tabular example, cloud is going to be a little bit different than desktop in that we don't show the kind of normal view. We always show the summary view that just gives you the count of the rows and columns. And but everything else beyond that still works in terms of the kernel. So this is one thing where we're a little bit behind, or we're a little bit different than desktop, but we're definitely still working towards getting parity there, and that will be coming soon in a future release. We do improved code assist features. In particular, we're adding syntax highlighting in the deployed view, which is also coming soon. But one thing that we've done in the past year or so for that is percent modernization, which Stephen talked about in his keynote. So we do have parity of that, in cloud as well. So that's one thing where we're maintaining and kind of going along with the desktop. Another key ask internally and externally is always improving the rendering quality of images and notebooks. And that's definitely something we're working on as well, hopefully in our next or soon release. And in general, we're just continually working on rendering performance improvements, particularly around dynamic and manipulate. As I talked about before, we have additional overhead between the front end and kernel, and we want to optimize that and move more things into the browser so that we're at least closer or as close as we can get to desktop performance. We're always going to be a little bit different than that, but we can certainly still make improvements there. And continued focus on native graphics in terms of rendering things purely in the browser and not having to rely on the kernel to generate images or other data to render that. And in particular, improve support for rasterbox, which is very key for that improved quality of image rendering that I talked about. And longer term projects, we're still planning to overhaul our editor to add more ability and features there. But again, that's a longer term project, and full dark mode support. As in John Voltz's talk yesterday, he talked about how much of an effort this was in desktop. There's a similar or even larger effort for us in cloud to work with them and other teams. Currently, cloud always assumes light mode. So it's not that your notebook breaks. We just assume light mode for your notebook, and we're still we're working on that, and that's still a long-term project to more fully support dark mode. Okay, all right. I think I've gone a little bit fast, although I'm running out of time. And then in cloud objects, we again want to prioritize performance optimization, better support for bulk operations, and improve documentation and workflows on how to use it, and also how we build different applications. Also continuing to improve enterprise support. We have auto-scalable deployments and options among different cloud providers. We have custom tune options for your specific use case, including large-scale API consumption or even LLM integration. We have customized containerized architectures. So again, I think as Stephen mentioned, we've long moved towards containerized architecture. And we're looking for some more initial adopters to partner with us on that, and some of the ways to have a custom solution for you. Overall, if you have a small, medium, or large project, please reach out and contact us, and we'll help you build the correct solution for what you need. Links to additional things, the cloud notebooks and notebook implementation notes, our release notes, which tracks all of our releases and gives some basic notes on fixes, which is also always a good thing to look at. And then I have an updated version of this talk with a link there. I made some slight edits, and you can kind of go from there. As I mentioned, related talks, we have office hours later today where you can ask more questions, particularly as we're running out of time here. And there's the compute services preview tomorrow at 11:30. I want to give a huge shout out to my team and their continued hard work, among them Philip and his group for that, and Mate, Konstantin, Kuba, and so forth. Evan and Emery in my notebooks team. Also want to give a shout out to the desktop front end teams and kernel teams that we work with, and without which none of the things we can do get there. All right, I've got like a minute. Anybody have some quick questions? Okay, so I missed the magnifying the cloud notebook because you're watching on a laptop. Apologies for that. The next one, can I short-term rent a cluster of CPUs in Wolfram Cloud? That'll be more about compute services. The Wolfram Cloud that we have is a more shared environment where we don't directly have an option for that, but that's going to be more about compute services. And then there is an ask for updating the file explorer dialog on the web app of Cloud. And some things there which we'll take into account for sorting. Cool. All right, I think we are at time. And again, if you have additional questions, please come to office hours or shoot shoot those questions to us through feedback forms. You can also message me directly or to customer support at Wolfram. So thanks everyone, and have a good rest of your day.